1.
Hi everyone, welcome to our Project Rebooted Hackathon project. We're team T.I.D.E, which stands for Thinking, Innovating, Designing, Executing. We're team number 23. My name is Zidhi Kumar, and these are my group members, Jay Patel and Shar Krishnan. And we basically created a project which uses the prompts of creating an interactive game and write a program that has an element of randomness in it. We created this fun game called Stop the Virus, which inspired from very real events that I think we all relate to. And it basically involves a player turning to shoot down these viruses that are randomly falling down using this vaccine that can shoot from different angles and can move left to right. So it also involving like basic physics into it. So I just want to say it's not an accurate depiction of how viruses work, just a fun video game. The only science we know is computer science. So I'm going to run the game and Jay's going to walk us through.
So this is our starting screen. We see two options here, start and exit. When we click start, the game starts. As you see, we have some viruses spawning. The left moving key is A, the right moving key is D. We also have a rotation feature where we shoot at an angle. Once we shoot these viruses, the score is increased. As you saw there, the virus collided with the player. Now we see the end screen. We have four things here. We have the score and the high score. We have two buttons, the replay and home. Let's see what happens when we click replay. The game has started again. But this time, let's see what happens if the virus or the bullet hit the floor first. As you see, the score is 0, but our high score remained from our previous attempt. Now, let's see what happens when we click home option. It takes us back to the main menu. Let's see what happens when we click exit. The game is stopped. So now that we're here, let's talk about some of our code. We used object-oriented programming throughout our software, and we use classes such as button. We also use another class such as block, and we use a class such as shooting. And in this class, we incorporated inheritance. And as we scroll down, we'll see some of the UI functions, and we see some functions that associate with our game and our mechanics. So as we go down, we see our game feature, game function. So in the game function, we'll scroll down and we'll see some while loops. And these while loops are essentially running the game. And the second while loop is for the end screen. So when we scroll down, we'll see some if statements, for loops. We'll get more into detail about that. But now I'd like to pass it on to Aditya.
Thanks, Jay. Let me go over how the block class and shooting class work. So basically, the block class is just a general class for all the sprites that you see in the game. And then each sprite is just a block object. So the vaccine's a block object, the bullet's a block object. So each of those different sprites, you have different methods of drawing them and moving them. And then for the shooting block, this is for shooting at those different angles and when you click on the mouse. And basically, it takes the XY coordinates from the mouse as target X and target Y parameters. And then we use those coordinates to create an angle using basic trigonometry with the arctangent function from the math library. And basically this angle is returned in radians, so it's a limit the angles, at what angle the player can shoot from. And we basically can imagine a vector with this angle at a certain magnitude. And using this imagined vector, we're able to generate these X and Y components of that certain magnitude using 20 times cosine of the angle and 20 times sine of the angle, which is from basic physics we can get that from. And these are basically these X and Y components, we add them onto the original X and Y, and this basically animates this bullet to move at its angle direction at a certain speed. So that's basically how the shooting works. And another part is the collision and how when the bullet collides with the virus, it needs to eliminate both of them from the list. So we use this nested for loop that allows for that elimination from the list. And similarly in the death class, we do the same type of function for when the virus bullet collides with the player. And we got to end the game when it does that. So now Jay's going to go over how the enemies randomly spawn and how they go from the randomization.
Yeah, okay, so for the element of randomness aspect in our project, we incorporated two parts. One aspect was the randomness of the enemy viruses, and one of them was the spawning of bullets from those viruses. We use this enemy X variable to generate a random X position, and we set the default to all Y positions to -10. Once we create these positions, we use a simple if statement to generate only a certain amount of viruses. As you see, we use the randint feature to only run when a randomly generated integer is equal to 15. We do a similar method using a for loop for the bullets of those viruses. We create bullets and only execute when a randomly generated integer is equal to 15. Now I'd like to pass it on to Shrad, who will talk about some of the user interface we incorporated in our code.
Thank you, Jay. So throughout our program, we use a lot of classes and inheritance, but we also implemented a UI. So in our UI, we use event for loops to detect when the player clicks any button or moves or drags their mouse across the screen. Along with this, we use Pygame to create various windows, as you've seen with when we ran our demo, and we implemented a lot of graphics and buttons to create a more approachable and fun user interface. And we also added music and various sprites and images to make the game experience more immersive for the player. So along with our program, we had a lot of complex algorithms mentioned, such as the colliding, the angles of spawning, And we use a lot of libraries such as the random math and Pygame. And we use a lot of images and PNGs and a lot of other files, and also use other various sources to help us get an idea of how to fix certain problems. So in terms of a challenge we face is balancing our school life and our work life. It was a bit of a challenge, but we hope to fix that in the future. So in terms of future goals, we want to make our game more harder, implement more levels, and potentially make the speeds more faster. So that it's a little bit harder for the player to really get to the next level. And we hope that we can one day publish our game on a website or even the App Store to make it more accessible to more people. Overall, we had a fun experience, and we hope you enjoy our product, the judges. And thank you so much, and we hope you have a great day.